Response 4. Consider the differential equation dy dx equals 6x squared minus x squared y. Let y equals f of x be the particular solution to this differential equation with the initial condition f of negative 1 equals 2. Time out before we do anything else. This is separable. If you factor out an x squared, you're going to get an x squared times stuff that doesn't have any x's and only has y stuff. So at some point in this problem, you're going to be asked to solve this. It's likely part B or part C, but it's going to happen. So, all right, cool. Part A. Use Euler's method with two steps of equal size starting at x equals negative 1 to approximate f of 0. Show the work that leads to your answer. So I do Euler's method as a table. You don't have to do Euler's method as a table, but that's how I do it. So the way I do Euler's method is I put my x and my y. I put my slope, which is this 6x squared minus x squared y. I'm going to yank the x squared out because I think it's easier, so I'm going to make it an x squared times the 6 minus y because I think that's easier. And then my new y, right, the new y that I'm going to get is the old y, right, y old, plus the slope times the change in x, right? And that's just point slope, right? It's y minus the y value, which you can then add to the other side, equals m, and then x minus the x value would be your change in x, right? So I know that I am starting when x is negative 1 and y is 2, and that I'm going by equal steps, and I'm supposed to end after 2 steps at 0. So that must mean I'm taking essentially a 0.5 step, from negative 1 to negative 0.5 to 0. And this is going to be my answer, right? So I know that the slope is negative 1 squared, which is 1, times a 6 minus 2, so I get a slope of 4. So my new y, right, so my new y is going to be the old y, which was 2, plus the slope, which is 4, times a 0.5, right, because I'm going by 0.5s. So that's a 2 plus another 2, which is totally a 4. So I put a 4 here, right? So then my new slope is going to be negative 0.5 squared. Well, a half squared is a fourth. It doesn't matter that it was negative because now it's positive. And then this is going to be a 6 minus 4, which is a 2, so I get that the slope is a half. So my new y, which is going to end up being my final answer, is the old y, 4, plus the slope, 1/2, times the change in x, which is also a 1/2. I did 2 1/2s here, so I end up getting a 4 plus a fourth, which is fine. So I get 4 plus 1/4. You can either write this as 4.25. If you're a decimal person, you can write it as 17/4. If you're not, either one's fine, right? I would not write it as a mixed number. Do not write 4 and 1/4. Mixed numbers are for shoe sizes and for cooking, and that's really it. Please do not use mixed numbers. So I'm going to say that f of 0 is approximately 17/4, or if you like it better, do 4.25. Please do not do mixed numbers. They go very, very wrong for us in a lot of ways. Sorry, ignore the alarm on my phone. All right, so part B. At the point negative 1, 2, the value of d squared y dx squared is negative 12. Find the second degree Taylor polynomial for f about x is negative 1. All right, cool. So in order to write a Taylor polynomial, right, a Taylor polynomial, so we're going to say p sub 2 of x, should be f of, so this is centered around negative 1, so it's going to be f of negative 1, right, plus f prime of negative 1 times x minus a negative 1, which would be a plus to the first, right, plus f double prime of negative 1 over 2 factorial times x minus a negative 1, which is going to be a plus quantity squared. That's my second degree Taylor polynomial, right there. That's what I want. So I just need these values, right? Well, I know f of negative 1 is a 2, right? This is a 2, right? I know f prime of negative 1 because I can find it, and we actually already did using our Euler's method, right? So f prime of negative 1, this is just going to be what happens if I evaluate dy dx, right, which we have evaluated at negative 1, 2, right? So we did that already. Remember that I pulled the x squared out, right? So I ended up making this a negative 1 squared times a 6 minus 2, which is how we got that that's a 4, right, times that x plus 1, right? And then they just gave us what d squared y dx squared is, right? So this thing right here should be d squared y dx squared evaluated at negative 1, 2, all divided by a 2, because that's what 2 factorial is. So it should end up being a, did they say negative 12? They did. Negative 12 divided by 2. So this is a negative 6 times the x plus 1 quantity squared, right? And that is my second degree Taylor polynomial. So p sub 2 of x is this. Oh, and if you didn't want to write it as plus a negative 6, if you just wanted to call it a minus 6, I get you. That's cool, right? All right, cool. Part C. This is what we were expecting from the beginning. Find the particular solution, y equals f of x, to the differential equation with that given initial condition. All right. So this part's not specifically BC. This is a very AB part of the question, and it is worth usually 5 or 6 points. In this case, it's 6, so you're going to be really bitter if you get this wrong. So I had already factored out the x squared when I used it previously because it was easier. So I'm going to go ahead and divide that 6 minus y over, right, and multiply the dx over to be with the x squared, right? This is separation of variables. If you don't do this on a separable diffie-q, you get no points out of 5 or 6, which is devastating to your free response supply. So your free response reply would be bad if you don't do this. Okay, then I'm going to do the antiderivative of both sides. Now, this is a natural log. The thing that people miss sometimes is that if you were doing u substitution, since it's a 6 minus y, you're going to end up with a negative in front of your natural log. So it's going to be the negative natural log of the absolute value of 6 minus y, right? And that's going to equal an x cubed over 3 plus c. We put the constant of integration on this side. Now, it's up to you how you deal with this. You can either plug in this value and find c now, which is fine, or you can solve for y first. But at this moment, right, you have 2 jobs left. One, you need to solve for y, because that's when they say y equals f of x, that's code for you have to solve for y. And the other thing you need to do is you need to plug in -1, 2 to find c. Now, there's a couple different ways to do this. I'm going to be honest, in a lot of the videos, I don't default to what I actually do, and I don't really know why, but in a lot of the videos, I plug in to find c first for you, and that's really not what I would do. I would use the rules that I know about how constants work and manipulate them accordingly to change stuff before I plug in. It doesn't matter to me which one you pick, but I'm going to do this one the way I really do these problems. So the first thing I would do, I'm going to do this first. I'm going to solve for y. It does not matter which of these two you do first. You're going to get the same answer. It just might look a little bit different. So the first thing I'm going to do is divide by a negative. So I'm going to get the natural log of this absolute value of 6 minus y equals a negative x cubed over 3. And I'm going to leave it as a plus c. I'm going to call it c sub 1, because if you divide an arbitrary constant by a negative, it's just a different arbitrary constant. I'm then going to exponentiate both sides, right? So I'm going to get that these cancel. Now here's my trick. I'm going to be able to essentially, ignore this c, right? Like what I'm going to be able to do is ignore this c if I want by changing this as an e to the c. And then we'll talk about this in a second, see how you feel about it. So I'm going to recognize that this is actually an e to the negative x cubed over 3 times an e to the c sub 1, which I'm going to rename as a c sub 2. What that does is it allows me to go ahead and ignore this absolute value, because the absolute value would care which direction was positive and negative, but if there's a constant in front, that constant being positive or negative would take care of my problem. So I'm going to go ahead and make this a 6 minus y equals c sub 2 e to the negative x cubed over 3. Okay, so I'm now here, and I'm going to need some space, so I'm going to erase at the top. So let me rewrite that. So I'm now at the point where I have 6 minus y equals c sub 2 e to the negative x cubed over 3, right? So I'm going to keep solving for y. I'm going to subtract the 6 over, so I'm going to get negative y equals c sub 2 e to the negative x cubed over 3 minus a 6, and then I'm going to divide everybody by a negative. So I'm going to get y equals, when I divide by a negative, I'm just going to rename this c sub 3 e to the negative x cubed over 3 plus a 6. Cool. So now I'm going to go ahead and plug in my point -1, 2 and see what happens, right? So I get 2 equals c sub 3 e to the positive 1/3, right, plus 6. So I'm going to get that this is a -4 equals c sub 3 e to the 1/3. I'm going to divide by that. I get -4 over e to the 1/3, and that's fine. If you wanted to call that your c sub 3, nobody would mark it wrong. The other way you might see this is a -4 e to the -1/3, right? So once I know that that's my c, again, it doesn't matter which one of these I pick, and I'm going to inch this way a little bit so you can see. So there's a bunch of different ways to write this. So I could write my answer as y equals a -4 over e to the 1/3 times an e to the negative x cubed over 3. That's not wrong, right? Totally fine. Sorry, plus 6. Missed my plus 6 there at the end. Right, because I'm copying this answer now just to find c. So that's one option, right? The other way you might see this is as a -4 e to the -1/3 e to the negative x cubed over 3 plus 6. That's also fine. Probably the most common way you're likely to see this is with the e's combined. So you're going to see this as a y equals negative 4e to the negative x cubed over 3 minus 1/3, all plus a 6. That's also fine. And then the final option, if we're being really like picky about all these different options that we have, is this negative 4e to the, and then you could actually factor out, if you wanted, a negative 1/3 and have this be an x squared plus 1, all plus a 6. Any of these are totally right. It's not your job to make sure that your answer matches the AP identically. It's your job to make sure that your answer is correct mathematically, and then the AP graders need to look and see if your answers are equivalent. So if you stopped here, nobody's going to mark it wrong. It's right. It just depends on, style preferences and where you go from there. So